Hello, students. This week we're starting into dimensioning, learning about dimensioning and some of the rules. Now, you're going to cover this a lot in your AutoCAD classes. So this 2-week unit you're doing on is a little bit about it, learning about dimensioning, but then doing math and calculating dimensions and see how they work together, and seeing how the different methods of dimensioning will affect tolerances, because we'll be getting into tolerances in a couple of weeks. So in your textbook here on page 191, there's this image that shows the placement and the sizing of dimensions. Okay, now, since we're doing most everything with computers, these sizes are already set up. So in AutoCAD, you use it with the dimension style that you've created. And all these sizes are set up for you, or you set them up when you create the style. The same way with Inventor and Revit. There's a dimension style that sets all of these sizes for you. The one thing to remember when you're placing a dimension is that we'll say this dimension here, there's 1.41. You would click this corner, and then you would click this corner. And then you pull your dimension out and place it up here. That gives you the gap between the extension line and the object. If you were to have just clicked this line to dimension it, then this extension line would have come down to here. So it would have come over the visible line. Or if you had clicked this corner to pull your dimension out, you would not have a gap there. Okay, so you need to be aware of that when you're placing your dimensions, irregardless of what software you're using. They work a little differently in how to place dimensions, but you want to be careful and be cognizant of that, okay? So this chapter, it's some reading that goes over the standards, how to place, placement of dimensionings, placement of some notes. You're going to see in a lot of the drawings, especially the drawings from the technical drawing with engineering graphics textbooks, most of those drawings in there are very old. So they're going to have some of the older standards of having words in the notes, okay, of, like drill and ream and different things like that, okay. So a lot of those drawings are very old, from like the first edition of the textbook. So it's got a lot of the old notes and old methods of dimensioning things. I'm just looking through the chapter here on some of this stuff on placing. Dimensioning is very easy in CAD because all you do is click things, and you place the dimension. So you have to really concentrate on where you're going to place it and where is the most obvious methods of placing it. And so on this page here, page 196, it gives examples of placements. Okay, and the idea of, I think they call it here contour placement. Yeah, contour dimensioning. So you place it where you see the shape that you're dimensioning. So like, for example, up here, yeah, it's, if these lines are, 0.21 apart and 0.42 apart, well, that, yeah, you could dimension them there, but you have no idea what the shape is that you're dimensioning. So it's better to place them here where you see the contour or the shape of what you're dimensioning. Same way with this, it's 0.285. Here you see the shape. Over here, you just see the height. You don't know what the shape is. Okay, same way with the 5.7, these different things here. There's multiple places you can put them, but better to place them in a shape, in a view where you see the shape. Okay. Uh, okay, so these two here, chain dimensioning and baseline dimensioning. A chain dimensioning is where you dimension straight through, and your dimensions are in a line. Okay, so here's an example of baseline dimensioning here, in which all dimensions come from a base or a datum. Okay, and your softwares will do this. There's a baseline dimension command in AutoCAD, so it automatically puts the correct spacing between them. Okay. Now, the reason we look at these things as opposed baseline versus chain, and within chain we've got broken and unbroken, and I'll show you examples. Okay, here in a minute, is when we start applying tolerances to these things. If we have baseline dimension and we have a tolerance, a generic tolerance, that tolerance gets applied to each of these dimensions, which means that if the tolerance is applied to here, that's okay. The tolerance is applied to the 0.75 and then to the 1.25. So the tolerances in this case do not build upon on each other. They're individual tolerances. So the overall length of the object would be no more than the tolerance applied to 1.75. If we're doing chain dimensioning, then the tolerance gets applied to each dimension in the chain, and it can affect the overall length of the object. Okay. Okay, so in a case like here, this would be unbroken chain dimensioning, in which it is dimensioned straight through. And if we applied a tolerance to each of these four dimensions, then the overall length, 2.125, would be 4 times the tolerance, because we have a tolerance applied to each one of these. So how you dimension it is based on what kind of tolerancing that you're looking for. Under normal circumstances, we would use broken chain dimensioning in that one of these would be left out, whichever one is the least critical. Okay. And you're going to get more into that as you get into your other classes in 1101 and 1103. I think that's pretty much the info that I wanted to cover from the textbook. In Blackboard this week, we're getting into these drawing quizzes and stuff from an older version of the textbook, and I have the quiz. There'll be the quiz, and then there'll be a drawing here. Now, excuse me, let me back up. This is my view of Blackboard here. This is not a student view. Let me pause and go into a student view, and I'll go down to week 9. Okay, so here we are in the student view. What you would see here, if we go down into week 9, and it was week 8. Yeah, week 8 is what we were just looking at. And so the first one was dimension calculation. So the quiz may come first, the image may come first. I can't resize that. So if you've got, I don't know, if you've got dual screens, there's 2 different ways you could do this. You could right click on the image and then open the image in a new tab, or you could download the image, if you want to do that. Or those supposed to be, oh no, this is new. I've never seen this before. I was putting an attachment to each of these, and I don't know where that one. Maybe this one did not get the attachment because I'm not seeing an attachment. Huh. I don't know what's happening with that. Anyway, so you could open it in a new tab or you could download it and save it. So it's up to you. That way, at least you've got something that you can go back and forth with when you're dealing with the quiz. Okay. And with these quizzes, there's going to be some questions. What's the height? What's the depth? Okay. What's the dimension for letter A? So let's look at this one here. So this would be letter A. And so you have to do the math based on the dimensions that you're given. Now, in all of these questions, you just put the numbers. Okay, the numbers and the decimals. Do not put inch marks or anything like that. Okay, just the number and the decimals. And that's how a lot of the worksheets that you're going to be doing in the next few chapters are going to look. Okay, so if you've got questions on any of this stuff, give us a call. Come by and see us in the lab, okay?